So we're going to be looking at problem number 34 from section 1-2 here for an example. Now, what's going to be good to distinguish here is the difference between an isocline and a solution curve, in particular when you're looking at a direction field. So for this problem, we're asked to sketch by hand the direction field for this equation right here, y prime is equal to negative t times y. And we want to draw some samples, some solutions. So in order to draw the direction field, you do have a couple of options typically. So you can either go sort of point by point and say, well, what about, at the point, if this is your t-axis and this is your y-axis, the point 1, 1, what would be the slope at that point? The point, say 7, 2, what would be the slope at that point, etc. Going through it. But that's a very labor-intensive process. However, if you use an isocline, you're typically able to much more quickly get a sense of what it's going to look like. So remember, an isocline is going to be a curve where at any point along it, your direction field would have the same slope. So an easy one to think is like, what about when the slope is 0, right? So think about that isocline. We'd say, well, that would mean y prime is equal to 0. Or, in other words, a 0 equals negative t times y. So maybe in, say, red, I'm going to put some isoclines in here. So I would realize that the slope is 0, so this is going to be my red isocline right here. Well, when does this happen? Well, when t is 0, so it's actually anywhere along this axis, or when y is 0, anywhere along this axis. So everywhere along these, you have this sort of this 0 slope. So along these isoclines, I could include sort of the slope along these. Right, and that's likewise the same down here. So because this is a constant solution here, you notice if you drop a leaf into the river that's flowing this way, this axis, the t-axis here, will actually be a solution as well, but that's a little bit ahead of us. So that happens to be an isocline and a solution. That is a very rare exception, really. All right, so let's also look at let's do a different color. I like this idea of keeping the colors distinct. What about where the slope is equal to positive 1? Well, this would occur when 1 is equal to negative ty, or you could write this as y is equal to negative 1 over t. So this right here is one of those hyperbolas. So if y is positive, t is negative, and it's asymptotic when t goes to 0, vertically asymptotic, and horizontally asymptotic when t goes to sort of negative infinity. So we have this sort of isocline right here, say, and you have one down here as well. And so anywhere along here has a slope of positive 1. So let's sketch those in. So everything along here has the same slope of positive 1. So let's do perhaps, let's say, negative 1 as well. Let's do this in maybe dark blue. So what about the slope equals negative 1? This will give you y is equal to 1 over t. So that would be this hyperbola here, or this one down yonder. So anywhere along here has a slope of negative 1. This is kind of a sloppy hyperbola there. I apologize. Maybe we should draw 1 or 2 more. If the slope is, say, positive 2, then what we're going to end up with is y equals negative 2 over t. So this is very similar to, I'm sorry, I meant to do it in a different color. Maybe we should make this one purple. So for the purple isocline here, that's going to be a steeper slope, so it's going to be this other purple right here, the steeper slope. Down here, the steeper positive slope than before. And then let's do one more. Let's do it in sort of a yellow. So what if the slope is -2? Right? Well, if that were to happen, then y would have to be 2 over t, which gives you curves in this area. And so along these yellow lines, you have even a much steeper downhill slope. So everything along here would have sort of a -2. To compare this to what it should look like, I have an image, and I'll pull it up here. So this is what the direction field should look like, and we see how we do have these sort of same size slopes according to these hyperbolas. So just like over here, we see in the bottom right positive slopes that get steeper as you go more towards, let's call it the southeast corner of this. And you have also positive slopes in the northwest section. And then we saw we had negative slopes in northeast and southwest, okay, or quadrants 1 and 3. For understanding where the solution would be, you ask, well, if I dropped a leaf in here, where would it flow? And it wouldn't necessarily flow along an isocline, right? Because as you look at the isoclines, maybe let's go back to our drawing here. I'm sort of jumping back and forth. If I were to drop a leaf right on this purple line here, it would immediately flow off of the purple line. It wouldn't stay on it because these lines are pointing away from that purple line. Occasionally, the lines happen to point along the line you've drawn, or so the slopes in this direction field happen to point along an isocline, but that's just a coincidence. Typically, it wouldn't. So if we were to drop a leaf, let's do this in, I think I have a bit of a whimsical brush here. Let's do it in stars. So if I did a leaf here, you would think, well, where would this flow? Well, it seems like it would flow. It would kind of go up a bit faster, and then it eventually would get pretty close to this, and then start to come down again. Right, because you see how it zeroes out along this axis here. So likewise, it gets sort of starts flowing this way. It steepens out for a while, but then as it moves to the right, the slopes over here tend to mellow out, and so there's sort of these dotted paths. Let's do that in maybe another color as well. If I were to drop a leaf along here, it seems like I would get it to flow directly across. If I were to drop it right here, it seems like it would flow that way as well. Now let's go back to the thing that will graph it for us and look at that and say, well, on this site, if I click on a place, it's going to give me a solution. So if I drop a leaf right here, so you see it sort of shoot up. If I drop a leaf over here, it goes like so. Drop a leaf right there. We saw that along the axis. Drop a leaf down here. Over here might be better. Great. So we can see how these are solutions which look different than the isoclines, but the isoclines are very helpful for understanding how the direction field works.